Okay, let's try problem 11.88 on page 361. The problem says, a sample of an unknown gas with a mass of 3.24 grams occupies a volume of 1.88 liters at a pressure of 748 millimeters of mercury and a temperature of 20 degrees Celsius. What is the molar mass of the gas? The molar mass of the gas can be obtained by getting the number of grams which are given divided by the number of moles. So it's the number of moles that we're going to solve for using the ideal gas law. Okay, to start any problem, you have to have your variables for your equation. Okay, so I have written down here what was given from the problem. It said that there was a gas, and there was 3.24 grams of that gas. That mass of the gas occupied a volume of 1.88 liters, and it was at a pressure of 748 millimeters of mercury and a temperature of 20 degrees. Okay, that's all that was given. So we know that because we have to use the ideal gas law, most likely we're solving for n because that's the only variable that we don't know. And r is the constant, which is always the same. And I've written it down here, 0.0821. And I've written the units of the gas constant. It's important to know your units because these units will help you remember what your variables units must be. That means I have to have a volume in liters. If milliliters was given, then you have to convert that. Okay, my pressure, which I know is millimeters of mercury, must be in atmosphere. So I know I'm going to have to divide this by 760, and I think that equals 0.8984 atmospheres. My temperature is in degrees Celsius, but it must be in Kelvin, so I'm going to add 273 to this, and that gives me 293 Kelvin. My N I don't know. So now let's use the ideal gas law to find out N. That's the most logical thing because I've got everything there except for N. My ideal gas law equation is PV equals nRT. I'm going to go ahead and put my variables in there. That I have 0.984 is my pressure. My volume is 1.88 equals N is my unknown. My gas constant is 0.821 and my temperature is 293. So to solve for N, I can divide both sides by 0.821 and 293. So I'm dividing 0.821 and 293 on this side. So I'll get N on this side equals to 0.0821 divided by 293. This answer will be 0.0769. So my 3.24 grams of unknown gas at a volume of 1.88 and a pressure of 748 millimeters of mercury at a temperature of 20 degrees occupies or has 0.0769 moles. So what's the molar mass? The grams would be 3.24 divided by 0.0769 equals 42.1 grams per mole. Now, if you want a little bit more challenging problem, let's look at Part B. Part B brings in a review of what we've already gone over a little bit, and that would be the empirical formulas from the chapter concerning moles. I can't remember offhand what chapter that is. But it says, in continuing, if the unknown gas is composed of 2.78 grams of carbon and the rest is hydrogen, what's the molecular formula? Okay, so this is a continuation of the problem. So what they're saying is that out of the 3.24 grams that you had initially, that's everything, carbon plus hydrogen, that 278 grams is carbon, and the remaining 0.46 grams is hydrogen. So what's the formula? Okay, so in getting the formula for empirical formulas like we did last time, or a few chapters ago, you must divide these by the molar mass of the elements to number of moles. So 2.78 divided by 12 is the number of moles of carbon, which is 0.232, and the moles of hydrogen, 0.46 divided by 1 is 0.46. So our little empirical formula is so far as C.232H 0.46. Now we know we can't have fractions there, so what we do is divide by the smallest number. So I'm going to divide by 0.232, divide by 0.232, and this gives us C for 1 and H2. Now in the problem, it said the molar mass of this compound, of this unknown gas, we calculated was 42. 42.14, say. So what's the molar mass of this? 12 plus 2 is 14. That's not right. So we need, this is empirical. The real formula is a multiple of this. So what's that multiple? We're going to divide 42 by 14. That gives us 3. And so we have to multiply each of these numbers by 3 to get the real formula. And we'll find that 12 times 3 plus 6 times 1 equals 42. And so the formula of this material is C3H6.